Dual Peering Overview. Welcome to our comprehensive guide on ExpressRoute Dual Peering, the ultimate hybrid connectivity solution that combines both private and Microsoft peering on a single circuit. This is the most sophisticated ExpressRoute configuration you can implement. You're essentially getting two networking capabilities in one: secure private connectivity to your Azure virtual networks, and optimized access to Microsoft cloud services like Office 365. What makes this powerful is the unified management and cost efficiency. Instead of deploying separate circuits for private and Microsoft peering, you get both on one premium circuit with shared bandwidth and management overhead. Today we'll build a complete dual peering implementation that serves as the foundation for enterprise hybrid cloud architectures. This configuration is what most large organizations eventually move toward as their cloud adoption matures. The complexity here is significant. We're managing two separate BGP sessions, different IP address spaces, route filtering, and security policies, all on the same physical circuit. But the benefits are substantial for organizations that need comprehensive Microsoft cloud connectivity. Comprehensive architecture. This architecture diagram shows the complete dual peering setup we'll be implementing. Notice how we have two distinct data paths flowing through the same ExpressRoute circuit. The private peering path handles all traffic to your Azure virtual networks using private IP addresses. This includes your IaaS workloads, virtual machines, and anything deployed in Azure virtual networks. The Microsoft peering path manages traffic to Microsoft cloud services using public IP addresses. This covers Office 365, Azure PaaS services like storage and SQL database, and Dynamics 365. The key insight here is traffic separation. Even though both peering types share the same physical circuit, they operate on different LANs and use completely separate BGP sessions. Your private Azure traffic never mixes with your Office 365 traffic. The route filter is crucial for Microsoft peering. It controls exactly which Microsoft services are accessible through your ExpressRoute circuit. Without proper filtering, you could receive thousands of Microsoft service routes. Notice the hub and spoke virtual network design on the Azure side. This is the recommended pattern for dual peering because it provides centralized connectivity management and security controls. Complex prerequisites. Dual peering has the most complex prerequisites of any ExpressRoute scenario because you need to meet the requirements for both private and Microsoft peering simultaneously. The premium SKU is absolutely mandatory. Standard tier doesn't support Microsoft peering at all. You also need significantly more bandwidth because you're supporting both Azure workloads and Microsoft cloud services. For Microsoft peering, you need owned public IP prefixes and a registered public ASN for private peering. You can use private ASNs and RFC 1918 IP space. The challenge is managing both sets of requirements simultaneously. IP address planning becomes critical because you need non-overlapping spaces for several areas: your on-premises network, Azure private networks, BGP peering subnets for both peering types, and your owned public IP space for Microsoft peering. The validation timeline is longer because Microsoft has to validate your public IP ownership for Microsoft peering while your provider provisions the circuit. These processes need to be coordinated carefully. Bandwidth sizing is challenging because Azure workloads and Office 365 have very different traffic patterns. You need to plan for peak usage across both types of services. Foundation with premium circuit. We're starting with the foundation, creating a premium ExpressRoute circuit that can support both peering types. Every parameter here is chosen specifically for dual peering requirements. The bandwidth choice of 5 Gbps reflects the reality that dual peering circuits typically carry more diverse traffic than single peering implementations. You're supporting both Azure workloads and Microsoft cloud services. Premium SKU and unlimited data are almost always the right choice for dual peering. The traffic patterns are unpredictable when you combine Azure IaaS and Microsoft SaaS services, so unlimited data transfer provides cost predictability. The Allow Global Reach parameter is enabled because dual peering scenarios often involve complex multi-site connectivity requirements. Global reach becomes valuable as your hybrid architecture grows. Location choice matters more for dual peering because you're optimizing for both Azure region proximity and Microsoft Service Edge locations. Central US provides good connectivity to both Azure regions and Microsoft's global service infrastructure. The tagging strategy reflects the complexity. We're tracking both the peering scenario and environment because dual peering circuits are typically shared resources across multiple business units. The service key process for dual peering involves coordination with both your connectivity provider and Microsoft's validation teams. This is where project management becomes critical. You'll provide the same service key to your connectivity provider for circuit provisioning, but you also need to start Microsoft's validation process for the public IP ownership required for Microsoft peering. The circuit status shows different validation states for different peering types. Private peering can be configured immediately once the provider provisions the circuit, but Microsoft peering requires additional validation steps. I always recommend starting the Microsoft validation process as soon as you create the circuit, even before your provider completes provisioning. This parallelizes the two longest lead time activities in dual peering implementation. The verification commands show how to check both provider provisioning status and Microsoft validation status. You need both to be complete before you can fully configure dual peering. Pro tip: create a project timeline that tracks provider provisioning, Microsoft validation, and your internal network configuration work streams. Dual peering success depends on coordinating these parallel activities effectively. Private peering configuration. Now we're configuring the private peering side of our dual peering setup. This handles all traffic to Azure Virtual Networks, using private IP addresses. The peer ASN 65003 is a private ASN that I'm using specifically for private peering. In dual peering scenarios, you might use different ASNs for private and Microsoft peering to provide better routing control and separation. The VLAN ID 300 is chosen to be distinct from the Microsoft peering VLAN we'll configure later. This traffic separation is critical. Private and Microsoft peering must use different VLANs on the same circuit. The /30 subnets for BGP peering come from private IP space since this is private peering. These IPs are only used for the BGP sessions between your router and Microsoft's routers. They don't carry user traffic. The shared key provides BGP session authentication. In dual peering scenarios, I recommend using different shared keys for private and Microsoft peering to enhance security separation. Once this command completes successfully, you'll have the private peering side ready. But remember, this is only half of our dual peering configuration. Microsoft peering comes next with its own set of requirements and parameters. Microsoft peering configuration. Now we're adding the Microsoft peering side to our circuit. This is where dual peering gets complex, because we're mixing private IP private peering with public IP Microsoft peering on the same circuit. Notice the customer ASN 65003. In this case, I'm using the same ASN for both peering types, but you could use different ASNs if your organization has multiple registered ASNs and wants routing separation. The VLAN ID 301 is different from private peering's VLAN 300. This is mandatory. Each peering type must use a unique VLAN for traffic separation on the shared circuit. The advertised public prefixes must be IP space that your organization owns and can prove ownership of. Microsoft validates this ownership before enabling the peering, which is why the validation process takes several days. The BGP peering subnets for Microsoft peering must come from your owned public IP space. You can't use random public IPs or private IP space for Microsoft peering BGP sessions. The routing registry name indicates where your ASN and public IPs are registered. Microsoft validates against these registries, so the information must be accurate and current. After this command, Microsoft peering will be in a provisioned state pending their validation. Private peering can be active immediately, but Microsoft peering requires the validation approval process. Route filtering is absolutely critical for dual peering Microsoft services. Without proper filtering, your circuit could receive thousands of Microsoft service routes, potentially overwhelming your on-premises routers. The comprehensive route filter we are creating covers the major Microsoft service categories that most organizations need: Office 365 core services, Azure PaaS services, and Dynamics 365. Each BGP community represents a different service category. This granular approach allows you to selectively enable or disable access to specific Microsoft services by adding or removing community rules. The allow access type means only the explicitly listed communities will be permitted. Any Microsoft services not covered by these community values will be blocked by default. This is a security best practice. Applying the route filter to the Microsoft peering is the final step that makes these rules active. Until you apply the filter, all Microsoft routes are blocked by default, which is the secure starting position. The route filter becomes a powerful tool for managing your organization's Microsoft Cloud Service access. You can add new communities as you adopt new services, or remove communities to restrict access to services that are not approved for ExpressRoute usage. The virtual network design for dual peering requires careful planning because you are supporting both private Azure resources and Microsoft Cloud services through the same network infrastructure. The hub virtual network serves as the central connectivity point for both peering types. The ExpressRoute gateway connects to both private and Microsoft peering, but routes traffic appropriately based on destination. The spoke virtual networks represent different environments or application tiers. Traffic from on-premises can reach these spokes through private peering. Meanwhile, Microsoft Cloud services are accessed through Microsoft peering from the same on-premises network. The virtual network peering configuration is critical. The hub must allow gateway transit so that spoke VNets can use the ExpressRoute gateway for on-premises connectivity. This centralized design simplifies management and security. Notice that the gateway subnet is sized appropriately for a high-performance gateway that can handle both types of peering traffic. The /26 subnet provides plenty of IP addresses for the gateway instances. The subnet design in the hub includes dedicated subnets for shared services like Azure Firewall and Bastion. These services often need to inspect or manage traffic flowing through both peering types. Creating the ExpressRoute gateway and connecting it to our dual peering circuit is where the final steps come together. This gateway handles traffic for both private and Microsoft peering types. The GW2AZ-SKU provides the performance needed for dual peering scenarios. Since we're handling both Azure workload traffic and Microsoft Cloud Service traffic, we need higher gateway performance compared to single peering scenarios. The zone redundancy is particularly important for dual peering because this gateway becomes a critical shared resource. If it fails, you lose connectivity to both your Azure vMIS and your Microsoft Cloud services. The connection creation links our circuit to the virtual network gateway. This single connection handles both peering types. The gateway automatically routes traffic based on whether it's destined for Azure private resources or Microsoft Cloud services. The routing weight of 200 provides path preference if you later add additional ExpressRoute circuits or connections. Higher weights are preferred in BGP routing decisions. The verification commands check that both peering types are working correctly. You want to see connected status for the overall connection, and you should verify that you're receiving routes from both private and Microsoft peering. Once this connection is established, you have full dual peering functionality. This includes private IP connectivity to Azure VNets and optimized access to Microsoft Cloud services, all through the same ExpressRoute circuit. VNet peering integration. Now we are completing our hub and spoke architecture by connecting the spoke VNets to our hub. This is where the dual peering setup really shines because all spoke networks get access to both peering types through the central hub. The VNet peering configuration is critical for dual peering scenarios. The hub VNet contains our ExpressRoute gateway that handles both private and Microsoft peering, and we want to share that gateway with all our spoke VNets. The allow gateway transit parameter on the hub side is what enables this sharing. It tells Azure that the hub VNet is willing to let other VNets use its ExpressRoute gateway for external connectivity. On the spoke side, use remote gateways is the corresponding parameter that tells the spoke VNet to use the hub's gateway instead of deploying its own. This saves significant cost and complexity. The beauty of this design is that spoke VNets automatically get access to both types of ExpressRoute connectivity. They can reach on-premises resources via private peering and Microsoft Cloud services via Microsoft peering, all through the shared hub infrastructure. This architecture scales beautifully. You can add new spoke VNets and they immediately get dual peering connectivity just by peering with the hub and enabling gateway transit. Traffic flow management. Understanding traffic flow in dual peering is crucial because you have two different types of traffic sharing the same physical infrastructure, but using completely separate logical paths. The traffic flow diagram shows how private peering traffic flows from on-premises to Azure virtual machines using private IP addresses, while Microsoft peering traffic flows to cloud services using public IP addresses, all on the same ExpressRoute circuit. The route table management becomes sophisticated in dual peering scenarios. You need to ensure that traffic destined for Azure virtual networks uses private peering, while traffic destined for Microsoft services uses Microsoft peering. BGP route advertisements play a critical role here. Your on-premises router receives two sets of routes: private IP routes from private peering for Azure virtual networks, and public IP routes from Microsoft peering for cloud services. The route verification commands help you confirm that both types of routes are being received correctly. You should see Azure Virtual Network routes with Source Virtual Network Gateway and Microsoft Service routes with appropriate BGP communities. Traffic engineering becomes important when you want to control which path certain traffic takes, especially if you have both ExpressRoute and Internet connectivity available for Microsoft services. Comprehensive security strategy. Security in dual peering requires a comprehensive approach because you're protecting both private Azure resources and controlling access to Microsoft Cloud services through the same infrastructure. The Azure firewall deployment in the hub VNet is strategic. It can inspect traffic flowing through both peering types. This gives you centralized security control over all hybrid connectivity. Network security groups work differently for each peering type. For private peering traffic, NSGs can inspect and control traffic between on-premises and Azure VMS. For Microsoft peering, NSGs are less relevant since the traffic is going to external Microsoft services. The route filtering we configured earlier is actually a security control. It prevents unauthorized access to Microsoft services that aren't approved for ExpressRoute connectivity. This is particularly important for compliance and governance. User-defined routes become powerful tools for traffic engineering and security. You can force certain traffic through the firewall, or direct different types of traffic through different paths based on your security requirements. The logging and monitoring integration provides visibility into both types of traffic flows, which is essential for security incident response and compliance reporting. Monitoring strategy. Monitoring dual peering requires a multi-layered approach because you're dealing with two different types of connectivity that have different performance characteristics and failure modes. The Network Performance Monitor provides end-to-end visibility from your on-premises network through both peering types to their respective destinations. This correlation is invaluable for troubleshooting performance issues. BGP monitoring is critical for dual peering because you have two separate BGP sessions. You need alerts if either session goes down, and you need to monitor the number of routes being received from each peering type. Service-specific monitoring becomes important for Microsoft peering. Office 365 service health events can affect performance even when your ExpressRoute circuit is healthy, so you need integrated monitoring that correlates network health with service health. The ExpressRoute Insights in Azure Monitor provides specialized dashboards for dual peering scenarios. You can see utilization, performance, and health metrics for both peering types in a single view. User experience monitoring is particularly valuable for Microsoft peering because it tells you whether your Office 365 optimization is actually improving the user experience compared to internet-based connectivity. Dual peering troubleshooting. Troubleshooting dual peering is more complex than single peering scenarios because you need to isolate whether issues are with private peering, Microsoft peering, or the underlying circuit infrastructure. The systematic troubleshooting approach I've developed starts with the foundation, circuit health and BGP sessions, then branches into peering-specific diagnostics based on the symptoms. For private peering issues, you're looking at traditional network connectivity problems, routing, firewall rules, NSG configurations. The troubleshooting is similar to other hybrid networking scenarios. Microsoft peering issues are often related to route filtering, BGP communities, or Microsoft service-side problems. The challenge is distinguishing between your ExpressRoute configuration and broader Microsoft service issues. The ExpressRoute troubleshooting tools in the Azure portal are particularly valuable for dual peering because they can test connectivity to both Azure resources and Microsoft services from the same interface. Performance troubleshooting requires comparing ExpressRoute performance against Internet performance for Microsoft services, and against baseline metrics for Azure private resources. The comparison helps identify whether ExpressRoute is providing the expected benefits. Performance optimization. Performance optimization for dual peering requires balancing the needs of two distinct workload types: Azure IaaS applications, which benefit from low latency and consistent throughput, and Microsoft SaaS services, which benefit from optimized routing and connection persistence. The gateway SKU choice becomes critical because the ExpressRoute gateway handles traffic for both peering types. ERGW3AZ provides the highest performance and supports fast path for private peering traffic when you need maximum performance. Connection pooling and persistence are particularly important for Microsoft services like Office 365. These services perform much better with persistent connections compared to the connection per request model that works fine for web traffic. QoS policies should prioritize real-time traffic like Teams and Skype for business over bulk transfers like SharePoint synchronization or Azure backup operations. The challenge is that both types of traffic share the same physical circuit. Regional optimization using BGP communities can significantly improve Microsoft service performance by ensuring traffic uses the most optimal Microsoft Edge locations for your geographic region. The performance metrics show realistic expectations for dual peering scenarios. You are typically looking at 20 to 40% improvement for Office 365 services and even greater improvements for Azure storage and database operations. Cost optimization. Cost optimization for dual peering is complex because you amortize the circuit cost across both Azure workloads and Microsoft Cloud services. The key is understanding which workloads benefit most from ExpressRoute connectivity. The bandwidth utilization monitoring helps you right-size your circuit. Dual peering circuits often see more consistent utilization because you have both Azure workloads and Microsoft service traffic, which can have different peak usage patterns. The unlimited data SKU family often makes sense for dual peering because the traffic patterns are unpredictable when you combine Azure IaaS and Microsoft SaaS usage. This provides cost predictability. Route filter optimization can help control costs by ensuring you are only paying for ExpressRoute connectivity to Microsoft services that actually benefit from it. Some Microsoft services perform just as well over the Internet. The hub-and-spoke architecture we have implemented provides significant cost savings by sharing the ExpressRoute gateway across multiple VNets instead of deploying separate gateways for each workload. Reserved instances for ExpressRoute circuits provide substantial savings for long-term dual peering deployments, especially when you are confident about your bandwidth requirements over a 1 to 3 year timeframe. Automation and infrastructure as code. Automation becomes critical for dual peering due to the complexity of managing two separate peering types, route filters, multiple VNets, and all the associated security and routing configurations. The ARM template approach I'm showing provides a complete dual peering deployment that you can customize for different environments. This eliminates the manual errors common in complex dual peering setups. Terraform is particularly powerful for dual peering because it can manage the dependencies between different components. This ensures that the circuit is provisioned before peering configuration, and that VNet peering is configured after the ExpressRoute gateway is deployed. The Azure policy integration helps maintain consistency across your dual peering deployments. You can enforce standards like requiring specific route filter configurations or mandating certain security controls. PowerShell automation is valuable for operational tasks like monitoring route advertisements, checking BGP session health, and updating route filters as your Microsoft service usage evolves. The CI/CD pipeline integration ensures that changes to your dual peering configuration go through proper testing and approval processes before being deployed to production environments. High availability and disaster recovery. High availability for dual peering requires planning for failures that could affect either peering type independently or the underlying circuit infrastructure that supports both. The multi-region dual peering architecture provides the highest level of resilience. You have ExpressRoute circuits in different regions, each with dual peering capabilities, providing geographic redundancy for both Azure and Microsoft service connectivity. Circuit redundancy becomes more valuable in dual peering scenarios because a single circuit failure affects both your Azure workloads and your Microsoft cloud services. The impact radius is larger than single peering deployments. The failover strategies need to account for both types of traffic. Azure workload failover is handled by your application architecture, but Microsoft service failover might rely on DNS changes or client-side configuration updates. Backup connectivity planning should include internet paths for Microsoft services. While ExpressRoute provides better performance, most Microsoft services remain accessible over the internet if your ExpressRoute circuit fails. The health monitoring and automated failover systems need to understand the difference between private peering failures and Microsoft peering failures, and respond appropriately to each type of outage. Dual peering success. Congratulations! You've successfully implemented the most sophisticated ExpressRoute configuration available, dual peering with comprehensive hub and spoke architecture, security controls, and operational excellence. Let's recap what we've accomplished. We've created a premium ExpressRoute circuit with both private and Microsoft peering, implemented comprehensive route filtering, deployed a scalable hub and spoke virtual network architecture, and established enterprise-grade monitoring and security controls. Your organization now has the ultimate hybrid connectivity solution. Users can access Azure virtual machines using private IP addresses through private peering, while simultaneously getting optimized access to Office 365, Azure PaaS services, and Dynamics 365 through Microsoft peering, all on the same circuit. The hub and spoke design provides incredible scalability. You can add new spoke VNets and they automatically inherit dual peering connectivity. You can expand your Microsoft service access by updating route filters. You can add new on-premises locations using global reach. The automation and monitoring practices we've implemented ensure that this complex configuration remains manageable and reliable. You have infrastructure as code for consistent deployments, comprehensive monitoring for operational visibility, and systematic troubleshooting procedures for issue resolution. Most importantly, you now understand the principles and practices for managing dual peering at enterprise scale. This knowledge enables even more advanced scenarios like multi-region dual peering, sophisticated traffic engineering, and integration with Azure Virtual WAN for global connectivity.